So today I want to make a video that is a setup guide for the Romer Arm product line with our products. So today I'm going to start off with DX and I'm just going to cover the absolute basics of how to get it set up for the first time and some of the settings that I check. So as far as the hardware part of it, we'll start there with this video on. I get the device out and set it up, and you see here that we have the mag base that they include with a lot of their products. I think it comes with almost every one. So we mag that down. We plug in all the necessary cables that it comes with. So it comes with a few there. There are 3 plugged into the back. Power and then 2 different types of communication, and I plug those into the machine itself. So you see here that I have an Ethernet and a USB connected into my computer. And there's a button here on the side that you can boot it up. But before you boot it up, you have to go download WinRDS from your Romer support or salesperson. They can send it to you. So that WinRDS is the software that communicates with the hardware itself, and then our software communicates with WinRDS to control it and receive the data. So you have to install that WinRDS before. It's good to install that before you start up the ARM. Also, after you install WinRDS, you should reboot. I usually do reboot because there are some things that WinRDS puts in your startup, and I just want to make sure that those are activated and everything. So I usually do that. So once you get WinRDS installed and plugged, you get the ARM plugged in and turned on. It'll beep when it turns on. Um, it if it connects, it'll go to this home position, which it should automatically look and connect to it. Um, so if it does not connect, then there's usually an issue with either your Ethernet adapter, and you just need to check that it's not set to static IP or some random thing from another product, and then get that going. So this is what should happen when you connect it up and turn on the ARM itself. Now, what I do before I actually go scan, I go into the hardware settings and just check their hardware settings. There's a few in here that I will utilize. Actually, because I opened this up before, it's automatically on the page that I usually change. So the RSX is the scanner section. I come in here and change my point sampling and even come in and change my active profile. So you do also have the option here to change the press to start and stop on the trigger button over here on the arm. If you just tap it, it will scan, tap it, it will stop. You can actually change that to press and hold, which is some people like to do that. Now, before I can change anything in here, I think it'll let me change certain things. So I can change it back to default or customize, but it won't let me change like the resolution here by default. And the reason why is I'm in this standard mode. You need to go over to advanced mode, and then the default password is advanced. And I capitalized it that time, so let me just double check. Oh, there we go. I accidentally typed both of them in the same area. So it is capital. Sorry for the problem there. It's a capital A advanced, and that will jump over. Apparently, I'm not advanced enough to get into the advanced mode. But once you do that, you can change your profile, even make a profile image. That's kind of crazy. I usually, because this device scans and captures so much data, I usually will put it down to 50 or 25%, somewhere in that neighborhood of the data. And I set the exposure to auto. In the latest versions, the exposure to auto, their auto, is very good, so I don't have to worry about it. Now, the reason why you would want to change this to manual is, let's say this part was perfectly white, or the whole thing is painted like the satin gray. If I change it to manual, I can adjust the exposure to match exactly that surface finish. And then the software doesn't have to work super hard. Their plugin doesn't have to work super hard. It'll just capture because you know the right setting. But when you're scanning lots of different types of parts, you switch it to auto, and it's very good at adjusting the exposure for the return that it's getting back to the sensor. So I will leave it on that. I leave this as default and go from there. Now, if you ever had any connections with the problems with the connection, sometimes it's because there are different types of like packs that you can put on the back, and you can tweak which control pack is on there, and you can talk to your Hexagon person to let you know which one to select here. And then you can connect this through USB, Wi-Fi, or Ethernet. Like you can select different. I just leave it on the defaults here. I don't really go crazy with that. And then you see the software's got a lot of stuff. You can come in here and you can probe and check your probe calibrations and all kinds of different things in here. You can adjust the volume and the sensitivity of the movement on screen, all that. But I don't really play around with that. I just come in here and make sure this is about 50 to 25. If I'm scanning a large object, I'll change it down to 50. I mean down to 25 because it's going to capture less data, and I need less data when I'm scanning a huge object. And then manual, and then hit save. So now we have set the arm itself. Now we can just go right over to live capture tab, go over to the drop down and go to Romer Absolute, because that's what I'm running here is the Absolute arm. You select that, you hit connect, and it will connect to the plugin. And then you're ready to scan. You can actually click scan right now and start scanning. But before I do that, I'm just going to cover, because this is a setup guide, some of the basic settings inside of the Design X plugin. So when you come in here, we will link to their software for calibration. So you can see I can click this and it will open up their software and bring it to the front. You can see probe alignment. I can go to the sphere plane alignment and go into their calibration. Let's just get back into the settings again. So these link to their settings. Like these are just shortcuts into this plugin here to change your probe, laser setting, or calibration. If you come over to general, you can adjust things like how it looks at the part as you move the scanner around and look at the part here. And you can adjust that. I just leave all of this alone. There's not that many reasons to change it, but you do have that ability to tweak that if you need to. In the probing options, you have this steady point thing where you can turn that on, and you'll see here that it's got a time and a range, and you can actually use the probe device to capture scan data as well. That's what this probe scan is. You can set either a millisecond or a distance, and then probe scrub the surface of a part and capture data. But there's lots of different, you can turn off the custom compensation, all these different options in here. I don't really adjust many of them. The big one that I will come in and tweak is whether I want to scan as mesh or point cloud. So you can actually tell this to scan as the base point cloud, or that automatically mesh it as you scan. And then these are the default settings, the 0.25, 3 millimeter for the meshing, remove outlier. Now, if you ever have a problem with point cloud or mesh, you can toggle over to point cloud and then hit raw data mode. And then you can have this auto save and change where it goes. Raw data mode will just take the raw data straight from the sensor without any of this processing on it. Most of the time, I don't do that. I actually go ahead and just capture the data as either a mesh or a point cloud. If I'm doing reverse engineering, a lot of times I just leave it as a mesh and go from there. Now, reasons you might want to change this is if you were scanning a very large object, having this fine a resolution is unnecessary sometimes, so you can bump this up. But I try to keep the same ratio between 3 millimeters and quarter millimeter as I jump up. So if I was going to double this to a half a millimeter, I might double this to 6 millimeters, just to try to keep this ratio of connecting the maximum grid resolution. And as you move really fast, this judges how far apart the rows of scans will connect back together. So if they're 3 millimeters apart, it'll still connect them. But if I'm moving really fast and they're 4 millimeters apart, it won't connect that together as one mesh. Device, we already talked about that. And then you do have some hotkeys that you can set for your scanner. So I just point out that those settings are there if you need to tweak them. I hardly ever do. Once you get it set up and ready to go, you can just come in here and hit live capture. So now I'm going to come over to live capture. And when you come into live capture, you'll see that there's two options. You can actually live capture laser data or probe data. At the moment, I don't have a probe on it, so I can't probe scan by touching the object that way. You do have the option in here to use a clipping plane, so I could scan this plane on the table and then set an offset distance, and anything below that plane, it just does not collect it as scan data. And as you see, what I have is the part suspended up in the air. I like to do that because with the scanner, I can get around it and scan faster that way, and then I can just crop this pole out later. So the scanner is ready to go. So I'll grab it. Make sure that you make sure this lock isn't on, because that lock will allow you to bring the laser down. You'll get this noise here when you're capturing data. Another thing that you can see is there is a dot and a laser. So you want to make sure the dot and the laser are close to each other. It's basically to show you your depth of field, so you know how far away to put the laser from the part itself. And you see the reason why I do it this way is I like to come around the part and just scan as much from one position as possible. And you can see one of the advantages of the arm itself is the fact that you can just get in and scan from all these different directions by hand, right? So I can scan up and see the bottom of the part. Like that. And you see I can get a lot of the part just from this one orientation. And then you see the viewpoint thing is this. If I rotate and look at the part from this orientation, you see it rotates it on the screen. That's what that setting was inside of the plugin. So this is how to set up and scan inside of DesignX. So once you're done, depending on the Romer arm that you have, there's a back button on the side or a trigger above the trigger. I can hit that and it will get out of the plugin. Now, right now, there is, the way the functionality works is the arm wants to be inside of the probe, the touch probe, when it goes through the menu. So it pops up with this little error. I just cancel out of it. And this is what's supposed to pop up. And then you can say exit live capture, or I can switch to probing if I want to. So if I say exit live capture, you see that we captured all of these polygons individual. Every time I pull the trigger here, it creates a scan. So that was the first scan right there, and then I pulled the trigger again, and then I pulled the trigger again. I touched it, and I just kept scanning the part. So that's the way it captures the data in these individual scans. And then from there, you follow the workflow that I've covered in some other videos where you can merge these scans and align it to the world and then start modeling. So this is how to capture scan data inside of DesignX. So now that we connected the arm and scan with the laser, which is by far the most popular data collection mode. I went ahead and installed the probe here on the arm, so you could, and depending on the arm, there are different methods for inserting it on here. There's a lineup tick mark here, and then there's a keyway, or in this instance, there's a little lever that you can use to install the probe. And with their devices, it will reinstall and then pull up the old calibration file for this. So I'm not a Romer person, so I'm not going to go through like how to calibrate the probe itself and all that. But when you stick it on there, it should pull up the older calibration. Again, I'll come over here and connect to the device itself. And then if it's time to capture some data, I can come over to live capture, and it'll ask me to switch over to the probing mode. So once you flip the switch on the arm itself over to probing mode, you also have to flip over to probing here in the live capture tab. There's a little probe icon. Now, this is just a raw like probe scan data collection. So you see here, what I'm doing is I'm just clicking on the surface here and just capturing points. And that's basically how you capture it. And then when you're done, you can exit live capture or switch over to scanning. But in order to scan with this one, you would have to pull the probe back off because the probe gets in the way of the scanner. So that's how you capture like raw points just by probing. You see here. You can barely see them on screen there, but there is a probing point cloud over here with 38 points in it. Now, if I wanted to probe geometry, I can come over here to probe live geometry, and then I will cancel out of that. And what you can do is you can toggle over to probe and then define what it is you want to probe. I want to probe reference planes. So you see here, once I pull the trigger on probe and I push the upper trigger to the left, and then it will record that. So you can see here, you can change it from reference planes to vectors. So if I did a vector and I just, okay, let's do that one more time. Let's just cancel out of that. Okay, so we are on, reference vectors by intersecting two planes, but you can do fit without compensation. There's all these different methods. I wasn't paying attention there. And you'll see it'll fit a vector through all the points that I collect there. There's all these different construction methods. Fit a vector from a cylinder. So this thing right here is a cylinder. It is not fixed very well, so this is not going to be a very accurate vector. And then it will calculate. So I didn't have very good, it moved around a lot. So I'll go ahead and get out of that. Now the third probing option here is to probe model something. So if you want to model surface bodies, I'll just switch over to surface, planes, and we'll do the same thing we just did before. Oops, I have to toggle over to probe again. And then back out, you'll see it creates surface bodies. And then just like before, except this is just different types of data here. Let's see if we can get it to create this time. There, we just created a cylinder from that. So you can just probe. Now everything comes in aligned to the base of the arm here. So if you wanted to do an alignment, what you would have to do is come over to here, live align. And with live align, you can do a couple things. I can select datums and I can probe those planes ahead of time. So I could do it that way. Um, or under best fit, you can scan a body and then best fit it together. So the way you would do a live align is by probing the features that you wanted to use to then go in and probe them again. So what I would say is one way to do it is just grab the 3 planes. Like a simple way of doing this would be your regular CAD planes. Like here, you select these like that, and then you tell it that I want to go probe those, and then you would probe 3 planes. If I had another plane here, and I could square it up, and then everything will come in aligned to the world to start out. But today's video is not really to go over that. It's mainly just the setup. So with Live Align, you can align the stuff to the world before you start. You can even use the laser to do that as well, where you scan the part, align the scanned part, and then come back in here and everything should be aligned. But I really wanted to cover the live capture, live model, live geometry. And then you do have probe location here, by the way, and we'll discard those changes. But probe location will allow you to come in and just put the probe on something and see its location and even capture that as a point. You see that? So you could just use this to measure, just measure things and capture probe locations. So that is an overview of the probing side of DesignX.